Pleasure to be with you today. This morning we're going to talk about modern medicine and ancient authority. Basically, we're going to talk about the practice of medicine based on the Word of God, because frankly, I think that's the only way medicine can be adequately practiced. I mean, so many people say, if you don't accept evolution, you can't be an adequate physician. You're denying science. Well, I took care of sick people for 20 years, and I don't recall evolution ever really coming up as an issue. I was just so involved in taking care of people. Those things just don't matter when you're actually applying the principles of observational science to what you're doing. But the world says, you've got to understand evolution. I submit this, you need to understand this. Genesis 1:1, in the beginning, God created the heaven and the earth. What we need to do always is submit to God as creator. He's the lawgiver. This word is the foundation of our thinking in every area. Yes, even the foundation of the practice of medicine. And this is something that doctors particularly need to remember. Genesis 1:26, and God said, let us make man in our image and our likeness. You know what the world says my patients were? According to the world, my patients were nothing more than rearranged pond scum. Over billions of years, chemicals just bumped together, and from the first single cell, man evolved. And over the next few 100 million years, who knows what we're going to evolve into. I have trouble with that. Over 20 years, I got to know and love my patients. I spent way too many nights in intensive care units or at the bedside of sick and dying and infirm people who are very dear to my heart. It's hard for me to think of them as rearranged pond scum. Those people were made in the image of the living God. And that's the way we need to look at our patients. But what the world tells us is something entirely different. According to the world, this is what man is. We're a curious accident in a backwater. We're a fortuitous cosmic afterthought, a tiny little twig on the enormously arborescent bush of life. You feeling good about yourself yet? Not yet? Well, I'm about to really cheer you up. What you are is just a bit of slime on the planet. We live in a universe which has no design, no purpose, no evil, and no good. Nothing but blind, pitiless indifference. How would you like a doctor that thinks that way? I don't want somebody caring for me thinking that way. But this is what the world tells us. The cosmos is all that is or ever was or ever will be. We're here by natural processes, just chemicals bumping together. Ultimately, we're just Mother Nature's science project. Evolution is the underpinning of everything we believe in biology, right? Well, that's what a lot of doctors actually believe. Evolution is the basis of biology. Biology is the basis of medicine. You're messing with something important when you mess with evolution. As I remember, there was an emergency room physician they got this quote from, and they were on an evolutionist tour of the Grand Canyon, which is kind of unfathomable to me because I can't believe you could spend 7 days in the Grand Canyon and not walk away saying, wow, the most unbelievable flood caused this. But what he's saying is, you've got to understand evolution to understand medicine, and I just really don't agree with that at all. The central unifying principle of biology is the theory of evolution, which includes both micro and macro evolution, and which extends to all species. How can someone who does not accept the most important theory in biology expect to properly practice in a field that's so heavily based on biology? It's hard to imagine how this can be so, but it's easy to imagine how physicians who ignore or neglect Darwinian aspects of medicine or the evolutionary origin of humans can make bad clinical decisions. The current crisis in antibiotic resistance is the result of such decisions. Dr. Michael Deeney said this, and he's a professor of biology at Texas Tech, and some years ago he actually went so far as to refuse to write letters of recommendation for students, even students who excelled academically, who accepted the creation worldview. If you did not accept evolution, he wouldn't write you a letter of recommendation. And he says, you can't be a good doctor if you don't accept evolution. His example, this whole issue of antibiotic resistance, which is a problem, but I'm going to submit to you, he totally misunderstands it, and we're going to deal with that. But he said, if you don't accept evolution, I won't even recommend you. Deeney's implication that a physician who fails to believe in his pet theory would also fail to remain a physician for long does not impress me. After 20 years in medicine, I believe the theory of evolution holds as much water as a colander. The theory in question has no relevance to clinical medicine. I would not hesitate to recommend a good medical student who failed to share my beliefs on the theory of evolution. Well, there's at least an honest opinion. Here's a really high-level intellectual opinion. It comes from me. I have also sought the input of many colleagues as to whether or not any evolutionary input is needed for them to adequately serve society in their capacity as physicians. Regardless of any individual's particular religious persuasion, many of my colleagues, being avowed atheists or theistic evolutionists, who mock me constantly for my young earth creationist stance, not one example could be put forth of the need for evolution or belief in its tenets to practice modern medicine. I've challenged doctors for years, show me one way that evolution affects what you do taking care of a sick person. I've never gotten any kind of response. It's just, you really need to understand this. How does it help you take care of grandma when she's sick? It doesn't really apply. Dr. David Minton observed this: if evolution were thrown out of consideration, it would have no negative impact. It plays no necessary role in either the teaching or practice of medicine. It's there, you talk about it, you give it lip service. Does it help you practice medicine? No. And I submit in many ways it's detrimental to the practice of medicine. Example one, this is an issue of the magazine Vanderbilt Medicine. It goes out to people who are house staffs at Vanderbilt and former students at Vanderbilt. And this entire issue was about monster bugs when bacteria and hospitals collide. It's all about antibiotic resistance. And pretty much the information you get here, you would get from any hospital newsletter, is pretty much the mantra of the age: evolution, evolution, evolution. That's what's causing this whole crisis in bacterial resistance. The Vice Chancellor for Health Affairs at Vanderbilt wrote this: the battle we wage with infectious disease is a struggle between two approaches to evolution: Darwinian evolution and intellectual evolution. Bacteria and viruses, for their part, evolve through random variation and natural selection. Bacteria continue to evolve to avoid the toxicity of modern medicine. Evolve, evolve. And I'm really not sure what he means by intellectual evolution, because based on the people I've known over the years, most people are intellectually devolving instead of evolving. But this is what Wikipedia says about antibiotic resistance, and I do not necessarily recommend Wikipedia as your primary source of information, but anyway, this is what it says. Antibiotic resistance is a consequence of evolution via natural selection or programmed evolution. The antibiotic action is an environmental pressure. Those bacteria which have a mutation allowing them to survive will live on to reproduce. And certainly I would argue this is natural selection, but look at the phrase carefully. It says evolution by natural selection. And folks, evolution, this is not. Bacteria often become resistant to the effects of certain antibiotics, and this is certainly an increasing problem in hospitals and in clinics. It's a very serious problem, and one that we need to spend a lot of resources and time trying to overcome, but I submit to you that many people are looking in the wrong place for the answers. After exposure to an antibiotic for a certain period of time, bacteria will become resistant to the effect of that antibiotic. And over time, there are an increasing number of bacteria that are becoming very resistant to multiple antibiotics. I mean, how many articles and news reports have we seen in the last couple of years about these superbugs and bugs that are more resistant to antibiotics? It's a huge clinical problem. When I was in practice, we used to get a report either weekly or monthly from our hospital lab talking about all the cultures and what antibiotics were becoming less effective and which germs were becoming more prominent in certain kind of situations. It's something doctors have to pay attention to. But this is how it works. Some bacteria are already resistant to certain antibiotics. Penicillin-resistant bacteria existed before penicillin was discovered. There are examples of resistant bacteria that have been recovered from frozen corpses who died before the use of antibiotics. So bacteria evolve into a state where they're resistant to something they haven't been exposed to yet. That doesn't sound like it's very inefficient, because evolution is supposed to be an efficient process over time where these organisms change to meet the stresses of their environment. So these bacteria are smart enough, they know that they're going to change to meet the stress of an environment they've never encountered, which is actually very convenient. Soil samples have revealed bacteria resistant to methicillin, which has never existed in nature, natively. I mean, it's a synthetic product. Mutations causing antibiotic resistance do occur. A change in the bacteria's DNA could lead to resistance. And this is kind of how it happens. Say there's a pump in the membrane that's used to pump nutrients into the cell, and this pump is used to, by the manufacturers, by the people who develop the antibiotic, to sort of have this pump the antibiotic into the cell so it can have its effect. If there's a change in the bacteria's DNA so the pump doesn't work, the antibiotic can't get into the cell, so the bacteria become resistant. Or say there's a particular site on the membrane or inside a cell where the antibiotic will bind. If there's a change in the DNA and this binding site changes, all of a sudden the antibiotic can't attach, the bacteria become resistant. The thing is, this ultimately leads to a loss of information. This is the opposite of evolution. This particular particular bacteria may have a survival advantage when exposed to that certain antibiotic or that environment, but in the native environment, you've actually got a structure or a mechanism that's not as efficient as it was before. So even though you have a survival benefit, you're ultimately losing information. For evolution to be true, you're going to have to what? Increase information. This is going in the opposite direction.